Welcome to this class. Today I am continuing the chapter Force and Motion of the subject Science and Technology of class 10. And today this is part 2. And in first part we were focused on gravitation and Newton's law of gravitation, but in this second part we are going to focus on capital G. Very interesting. Capital G. What it mean? Gravitational constant. We are going to focus on gravitational constant and another matter also, that is the factors which affects the gravitation, and later we will talk about the consequences of gravitation also. Okay, let's start. First we are going to talk about gravitational constant and consequences of gravitation. Do you remember the Newton's law of gravitation? First we have to recall this Newton's law of gravitation, and then only we will be able to understand gravitational constant. Look at this. According to Newton's law of gravitation, which I did in previous class, according to Newton's law of gravitation, the gravitational force between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. It was taught in previous class, and this is Newton's law of gravitation. I don't want to go to detail. With the help of this law, we derived this equation in previous class. F equal to capital G m1 m2 by d square. Here F is gravitational force, m1 and m2 are the masses of two bodies, and d is the distance between them. But capital G is gravitational constant, and we are going to focus on this capital G, gravitational constant. Exactly what is it? Better to take one example. With the help of animated this figure, we can understand this. This is, let's say, 1 kilogram mass, and another 1 kilogram mass is also taken. It means both are unit masses. Unit mass means what? Unit mass may be 1 kilogram or 1 gram or 1 pound, but according to SI system, 1 unit mass means 1 kilogram mass. And here we have taken two 1 kilogram masses, two unit masses, and they are separated by a distance 1 meter. They are separated by 1 meter distance. Now the force of attraction between these two is taken as gravitational constant. Any body, if it has mass, then it attracts another body having mass, and this 1 kg mass attracts another 1 kg mass towards its center. The force which involves between two unit masses separated by a unit distance is gravitational constant. That's why we can define this way. The force of attraction between two unit masses separated by a unit distance is called gravitational constant. It is denoted by the symbol capital G. Don't be confused, not small g. Small g represents acceleration due to gravity. That comes later. Later we are talking about acceleration due to gravity also. This is gravitational constant and is denoted by capital G, and its value is 6.67 into 10 to the power minus 11 Newton meter square by kg square. We'll talk in detail about this value also later, but I want to focus on constant. Constant, have you heard about this? Yes, it was taught in class 9. If you remember, when we derived F equal to ma with the help of Newton's second law of motion, at that time K came in the derivation. There was F equal to kma, which came in the process, and at that time K was removed, and removal of K, I want to tell you the reason of removal of K. Okay, look at this. If K is taken to one of the side, then we will have K equal to F by ma. If we take the unit of force, mass and acceleration, then the same equation can be written this way. This is the unit. Force is measured in Newton, mass is measured in kilogram, acceleration is measured in meter per second square. And if we expand this Newton, the expanded form of Newton is kg meter per second square. It was taught in unit number 1, if you remember, and it was taught in class 9 also, and we revised this in unit 1, scientific study also. Newton, its expanded form is kg meter per second square. Now look at this, both the unit in numerator and denominator are equal and they cancel each other, k becomes 1. If k is 1, then when m and a, ma multiplies k, then what happens? The result will be just ma. That's why should we take this k? That's why it is removed. It was removed in class 9 when we proved f equal to ma, because value of k is if 1. It's not necessary to take in the equation. This is just the constant, its value is 1. So we declared that f equal to ma at that time. Now what about our g, capital Z, gravitational constant? This is also a constant. Can we say that g is equal to 1 or not? We can convert all these. I mean to say, we can put the unit of all these physical quantities, and if g comes 1, then we will remove g from this place. Okay. Now if we take the unit of force, mass and distance, then we will get this equation. In this equation, if we take just the unit only, force is measured in Newton, mass is measured in kilogram, distance is measured in meter. And if g is taken to one of the side, then we will get this. And if we expand Newton, then we will get Newton as kg meter per second square into meter square, kg into kg, and one of the meter cancel each other here, and 1 kilogram will be cancelled from this denominator and numerator. Then we will have this, and meter square into meter becomes meter cube upon second square upon kilogram, like this. And if we take all these quantities in numerator, then we will have this unit. It means what? It means these are the fundamental units involved in gravitational constant. Unit of gravitational constant involves meter thrice, kilogram once, second twice, and kilogram once divides the meter cube, and second twice divides the meter cube. This is the fundamental unit involved in gravitational constant. But we cannot reduce this unit into other primary unit. This is the last. It means g is not equal to 1. Like k, g is not equal to 1. If it is not equal to 1, then certainly it has certain value. If it has certain value, then we cannot remove g from the equation. F equal to g m1 m2 by d square remains the same. G cannot be removed. Okay. What is the reason why we are not removing g? It's clear, isn't it? Now let's go back to the same. The force of attraction between two unit masses separated by unit distance is called gravitational constant. Now I want to talk about the value. Look at this, 6.67 into 10 to the power minus 11. This is the value of capital G. Now, if 10 to the power minus 11 is taken in denominator, then we will have this. Minus 11 becomes plus 11 in denominator, isn't it? And what is the meaning of this? 10 to the power 11 means 1 having 11 0. We can write like this. 10 to the power 11 means 1 having 11 0. Now, if 6.67 is divided by 1 having 11 0, this is equal to 1 kharab. Now we will get this 0.00000. After 10 zeros, then only 667 comes if we divide 6.67 with this number. Now, what is this? Why I am doing all this? Because I want to tell you that the force of attraction between two 1 kg masses is so small that millions of times smaller than 1 Newton. Millions of times smaller than 1 Newton. That's why I want to say this, the attraction between two 1 kg masses is very less, millions of times less than 1 Newton. And at first it was declared by Henry Cavendish. He made a balance like this. This is Cavendish balance. It occupies the whole room. It's a big balance. It's not like a normal type of balance having two pan. This is special type of balance he created, and by the use of this Cavendish balance, he declared that the gravitational force between two bodies, if we measure, then a constant involves between them. This constant is capital G. Its value is 6.67 into 10 to the power minus 11 Newton meter square by kg square. Very small value of capital G, also declared by Cavendish. Okay, this is just for information. We don't have to go through this balance. We don't have to know the mechanism of working of this balance. We don't have to know the method of measurement of gravitational constant. Just for information only, Henry Cavendish found the value of capital G. Okay. Now, one question is very famous question, usually asked in examination also. In which condition the value of capital G will be equal to gravitational force? Value of capital G is equal to gravitational force, means capital G equal to F, gravitational force F. In which condition? I want to tell you about this. According to Newton's law of gravitation, we know that this is the equation. Yeah, this equation is declared because of this Newton's law of gravitation. Now, in this case, what happens actually, if m1 is the mass of first body, m2 is the mass of second body, and d is the distance between them, which we can write as shown in the figure or diagram. If m1 equal to m2, both are equal to 1 kilogram and d is 1, then if we take this value, unit mass and unit distance, then what happens? 1 multiplied by 1 divided by 1 becomes what? F equal to G. This is the condition. In which condition the gravitational constant, the value of gravitational constant is equal to gravitational force. In this condition, when two unit masses are separated by a unit distance, then capital G, gravitational constant, will be equal to gravitational force F. This way we have to answer this question. We have to start from according to Newton's law and we have to end at this place. Gravitational force is equal to gravitational constant in this condition only, otherwise not. Okay. After the understanding of this gravitational constant, now let's go to some other topic. What I told you, we are talking about consequences of gravitation. Gravitation is the force of attraction between any two bodies of this universe due to their mass, isn't it? What are the consequences of gravitational force? This is our focus point now. Now, have you noticed this? Do you recognize this? What is this? Actually, this is a video clip of galaxy. One of the galaxies is spiral-shaped galaxy. Millions of stars are present in this spiral-shaped galaxy. And why they are collected at a place? Why they form this system? Why? The reason is gravitation. That's why one of the great consequences of gravitation is existence of galaxy is because of gravitation. Because of gravitational force, galaxy exists. And this universe is full of galaxies. There are millions of galaxies in this universe, and in each and every galaxy there are millions of stars. They held together because of the gravitational force. That's why one of the great consequences of gravitation is the major component of universe is galaxy, which is the vast collection of millions of stars, and the universe is full of galaxy. This is one of the great consequences of gravitation, that the universe exists because of this gravitation. Now next, what is this? Can you recognize this? It's very easy. Solar system. And in the center there is sun and there are planets revolving around the sun. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. There are 8 planets which revolves around the sun. And why they revolve around the sun? Because of the gravitational force. And why this planet revolves around the sun? Because mass of sun is very huge. That's why all the other planets, they have very small, comparatively very small mass. They revolve around the sun because of the huge gravitational force. Now this is because this solar system exists because of gravitational force. Another great consequence of gravitation is solar system exists due to gravitational force. I want to tell you one more consequence. Look at this, is interesting. Yeah, this is one of the sea beach. Here it is dry, here it is full of water. The same place, sometimes dry, no water at all. Very less amount of water appears at this place, otherwise not. And now it is full of water. What is the reason behind this? This is because of tide. Do you know what is tide? The rise and fall of level of water in the sea and ocean is called tide. Sometimes the level of water rises up and again it falls down. This cycle occurs after every 6 hours. At this time, if level of water in the sea is high, then it is called high tide. After 6 hours, it goes down and becomes minimum, that is called low tide. High tide and low tide. The cycle of high tide and low tide occurs after every 6 hours. Just remember this. And what is the reason behind this? Gravitational force. Gravitation. How gravitation? Earth is rotating around its own axis. The part which is turned towards the moon, if there is sea and ocean, then certainly moon attracts the water of the sea and ocean and level of the water rises up and it appears like this. At this time, this part of the sea is facing the moon. Moon is just in front of this sea and that's why the level of water raised to maximum value. And Earth, when rotates around its axis, after 6 hours, it moves away from the moon. And then what happens? Now, level of water goes down. Level of water goes down and low tide occurs. This type of low tide. Water gone away. Yes, not completely, level of water gone down, which can be understood with the help of this diagram. And again, after 6 hours, what happens? Here we have moon, here we have Earth, and if the same part is gone just opposite, then what happens? The water of this sea rises up, and in opposite direction also, to balance the force of attraction of the moon, water level rises in opposite direction also. That's why again we will have high tide. In this way, after every 6 hours, there is high tide and low tide. And this is because of what? Moon's gravitational force. Okay, now I want to show this separately. Look at this. The same place after 6 hours appears like this and this. And after 6 hours of this. And another place also I want to show here. Water is, here we have lot of water, here less amount of water. During high tide, water fills up the space and during low tide, water goes down. This consequence is of what? Gravitation. Gravitational force of moon. And we can conclude that the tide on the sea forms due to the gravitational force of the moon. Now after this consequences of gravitation, now we have to go through a numerical problem. Before the numerical problem, we must have a little idea how to deal with power of 10 in number. Look at this. We are going to solve some numerical problem, but before entering into the numerical problem, you must have a little idea about the power of 10. Then only we will be able to solve the numerical problem. So, I want to tell you about the power of 10. How to write very big number in power of 10. If we have very big number like this, 23 crore 58 lakh 43,289. It's a very big number. If we have to multiply this big number with another similar big number, then this becomes very irritating and this becomes very frustrating also. How do we handle this big number? Now, there is a method which is created later. We can write this big number in power of 10 this way. Here decimal point is somewhere here, because no any decimal point here. That's why decimal point lies at the end here. And if it is shifted to this place, means after one digit, that is 2. And if it is shifted to this place, then how many digits it goes left hand side? 1, 2, 3, 4, 5, 6, 7, 8. This, if written as this, then these two are not equal. This is 23 crore 58 lakh 43,289, but the second number is just more than 2 and less than 3. These are not equal. To make them equal, we can multiply the second number with 10 to the power 8. Why? The reason is very simple. Since the point is shifted to 8 digit left hand side, 1, 2, 3, 4, 5, 6, 7, 8. So, if this number is multiplied by 10 to the power 8, then what happens? This expression will be equal to this expression, 23 crore 58 lakh 43,289. This also equal to the same. But we cannot handle this lot of number after this decimal points. So, it is general practice to express in average. In average, what we do, after decimal point, normally we are taking 2 digit. After decimal point, we are taking just 2 digit. Third digit is 8. If third digit is 5 or more than 5, then we'll add 1 to second digit and we'll write 2.36, and remaining digit can be removed. And this is the average value. Look at this like this. Here third digit is more than 5. That's why 1 is added to second digit, and in average we can say that 2.36 into 10 power 8 is equivalent with this second expression. Yes, and this number is used while solving the numerical problem. Yes, this way we have to deal with power of 10. Now let's talk about the very small number also. How to write very small number in power of 10? Let's take previously we did this 0.0000667. This is value of gravitational constant, isn't it? And this very very small number, millions of billions of times less than 1. Now how to write this? We can shift this decimal point from this place and we can put this between these two 6 like this. And since the decimal point is shifted towards right hand side and it moved to 11 digit right hand side, that's why the same number, this 6.67, should be multiplied by 10 to the power not plus minus 11. Then this expression will be equal to this. Numerically both are same, equal. This way we have to deal with power of 10. If we shift decimal point to left hand side, then we have to multiply that expression with 10 to the power something, how many digits shifted? 10 to the power positive number. And if we are shifting decimal point to right hand side, not left hand side, if right hand side, then we have to multiply that expression with power of 10, but the 10 to the power negative. This way we have to deal with power of 10. Now we are able to solve the numerical problem with power of 10. let's go through one numerical problem. This is one of the numerical problem. I am going to present this. Two objects are at a distance of 400 meter and the distance between them is 4.16875 into 10 power 4 Newton. Look at this, power of 10 is coming. And if mass of one of them is 2 into 10 power 7 kilogram, what it means? 2 10 power 7 means 1 having 7 0 multiplies 2, isn't it? But we are not writing very big number, we are writing in power of 10, 2 into 10 power 7 kg. Calculate the mass of another. First, we have to write the information given this way. First, what is given here? Distance is given and then gravitational force is given. That's why I am writing the value. Distance d equal to 400 meter, gravitational force F equal to the given value. And then another, the mass of first body is given. That's why mass of first body, we can take the symbol m1 is equal to 2 into 10 power 7 kilogram, and we have to find out the mass of second body m2. But one of the factor is missing, one of the quantity is not given, that is g, capital G. If not given in the numerical problem, we can write ourselves, because this is one of the important value. We have to remember this with unit, and if not given in the numerical problem, then we can write this value. Gravitational constant capital G is 6.67 into 10 to power minus 11 Newton meter square by kg square. Okay, now we are using equation. We have what equation we have? F equal to G m1 m2 by d square. And if we take the value G, value of G is taken here and F is taken in left hand side, G is taken here and m1 and m2 are taken. M2, we have to find out m2. D is 400, 400 is square. Isn't it? If 400 square is taken to left hand side, then we will have this expression in left hand side. In right hand side we have this. And now if m1 is taken in one of the side, then we have to take this 13.34 into 10 power minus 4 in denominator this way. And if we take this 10 to the power 4 in the numerator, it becomes positive 10 to the power not minus 4 plus 4, and this number can be divided by this number. Number interacts with number and power of 10 interacts with power of 10. That's why if we divide this number with this, we'll get this value. You can use calculator. And 10 to the power 4 and this 10 to the power minus 4 gone up in numerator, and we have now 10 to the power 4. 400 square means what? 4 4s are 16, and if 2 zeros are here, then square makes it 4. Now this is the value. 400 square means this is the value of 400 square. Again we have to convert this into power of 10. 1.6 into 1 2 3 4 5 10. 1.6 into 10 power 5. We'll write that like this, because point is shifted to 5 digit left hand side. Okay, now 1.6 multiplied by 0.3125 gives what? It gives 0.5. Now 10 to the power 8 and 10 to the power 5 are still there. Now the final number is 0.5. Why should we take point number? It can be converted into whole number also. If point is taken to right hand side, then we can multiply this 5 with 10 to the power minus 1, because one digit right hand side point is shifted. Now 10 to the power minus 1, 10 to the power 8, 10 to the power 15, all of them have same base. If they have same base, then power can be added or subtracted. 10 to the power minus 1 plus 8 and plus 5 gives 8 plus 5, 13 minus 1 is 12. The final answer is second mass is equal to 5 into 10 to the power 12 kg. That's why we can declare that. Therefore, mass of second object is 5 into 10 to the power 12 kg. Okay, it's clear? Seems to be difficult, but if we know how to deal with power of 10, then the same numerical problem becomes easier. First, we have to write the information given, and then we'll not write these units in the process. Have you noticed this? I am not writing unit in the process. It's not necessary to write. If you are interested, you can write, and you have to go through the unit also till the answer. Otherwise, it is not necessary to write the unit in the process. First we'll write, and in the answer also you have to write the unit, but in the process you can ignore the unit. This part is finished. Now, let's talk about relation of gravitation with mass and distance. Now we are talking about this. This is our last part. We have to take some example. Gravitation is related to mass. If mass increases, gravitation increases. If distance increases, gravitation decreases. Now we have to go through proof with the help of equation. Look at this. What will be the change in the gravitational force between two bodies when one of the mass is doubled? Let's say we have two masses m1 and m2 separated by a distance d. Then according to, let mass of two bodies are m1 and m2 separated by the distance d. Then according to Newton's law of gravitation, what? F equal to g m1 m2 by d square. This we know. This is, let's say this is equation number 1. Now what is the question? What will be the change in gravitational force between two bodies when one of the mass is doubled? One of the mass means either m1 or m2. One of them is if doubled. When one of the mass, let m1 is doubled, then we can show with diagram also this m1 is doubled. But actually you don't have to show with diagram in the examination, but to make you very clear only, I am showing diagram. Otherwise this diagram is not the compulsory part of the answer. Okay, if mass of first body is doubled, then the same equation becomes what? Force, new gravitational force will be equal to g remains same. m1 is now 2m1, m2 same, d same, isn't it? And if this 2 is taken to this position, then we'll have new gravitational force 2 times g m1 m2 by d square. Now compare equation 1 and 2. G times m1 m2 by d square is equal to f. And if we compare this with first equation, then we have now 2 times f. Comparing equation 1 and 2, what we have? New gravitational force is equal to 2 times the previous gravitational force, f. So now we can conclude that therefore new gravitational force between them is 2 times the old gravitational force when one of the mass is doubled. Clear? Now let's go through another. When the mass of both the two bodies are doubled, what will be its effect on the gravitational force between them? We have the same equation, same diagram m1, m2, d, and the gravitational force between them is what? F equal to g m1 m2 by d square. It was just told before this slide also. I told the same. Till now same. But now what we are doing? Both mass of both the bodies are doubled. When m1 and m2 both are doubled, when both the masses are doubled, then what happens? Then same equation will be different. Look at first mass is also doubled, second mass is also doubled. Then we'll have new gravitational force g 2m1 2m2, mass is doubled, that's why 2 2s are 4. If 4 is taken first, then F nu becomes 4 times g m1 m2 by d square. If we compare these two, then new gravitational force will be 4 times greater than the previous gravitational force. We can say that comparing equation 1 and 2, new gravitational force is equal to 4 times the previous gravitational force. We can conclude this in sentence also. New gravitational force is 4 times greater than the old gravitational force. It's clear? Now I told you about the effect of mass. Increase of mass increases the gravitational force. How we can prove with this equation? Now next. Now we are talking about distance. What will be the effect on the gravitational force between two bodies if the distance between them is doubled? In previous case we are talking about mass, now we are talking about distance. We have m1 and m2 two masses separated by a distance d, and according to law of gravitation, this F equal to g m1 m2 by d square. But now we are increasing distance by twice, 2 times than that of the previous. If distance is doubled, if they were in this position, m1 and m2 was in this position, now it is taken away, double distance. Then we can say that distance is 2d. Now new gravitational force will be equal to capital G m1 m2 by, instead of d I am writing 2d, and d square means 2d square. Now 2 square is 4, d square remains same. F nu equal to G m1 m2 by 4d square. If this 4 is taken as constant, 4 is a constant, if taken at this place, then we will have F nu is equal to 1 by 4 G m1 m2 by d square. If we compare this, when we compare equation 1 and 2, what happens? This new gravitational force is just 1/4, 4 times less than that of the previous gravitational force. It is quadrant than that of the previous. Look at this, F nu is equal to 1 by 4 F, and we can conclude that new gravitational force is quadrant of the old gravitational force. When distance is doubled, then gravitational force reduces by 4 times. If distance is half, then what happens? What will be the change in the gravitational force between two bodies when the distance between them is halved, decreased? Now, same way we can write this m1 and m2, they are separated by distance d, mass is included here. According to Newton's law of gravitation, g m1 m2 by d square is first equation. When the distance between them is halved, then what happens? Instead of d, we are writing half d. Let's say previously the body was in this position, now taken to this position, distance is half. Now the same equation becomes what? F nu is g m1 m2 by d by 2. 1 by 2 d means d by 2 square. And this is equal to what? D square by 4, 2 square 4. And 4 goes up in numerator. Now we have this equation, 4 times capital G m1 m2 by d square. If we compare these two, new gravitational force is 4 times greater than previous gravitational force. Comparing equation 1 and 2, F nu equal to 4 times F. This way we can conclude that new gravitational force between them is 4 times the old gravitational force. Is this clear? So many things we did today. We started with capital G, gravitational constant, and I told you the consequences of gravitation or gravitational force, and I told you about the relationship between the gravitational force and mass and gravitational force and distance. We did certain derivation also. I think I made this matter clear to you. Now this is the end of class. Now in next class I'll meet with you with some other matter. Thank you.